Hi there, welcome to edupediaworld.com. We are discussing the videos on triangles. So in this video we'll discuss some of the extra questions related to properties of triangles. Now the first question is, in triangle ABC, AD is the perpendicular bisector of BC. Now we need to show that triangle ABC is an isosceles triangle in which AB equals to AC. Now it's given that in triangle ABC, AD is perpendicular bisector of BC. Now we need to show that ABC is an isosceles triangle, okay, in which AB equals to AC. So we need to prove triangle ABC is an isosceles triangle, okay, or we need to prove that AB equals to AC. Now let's say how we can prove this. So we can say that consider triangle ABD and triangle ACD. Now it's a perpendicular bisector, so we can say that first of all angle ADB equals to angle ADC. You can say that each 90 degree. Okay, now so the second part can be AD equals to AD, which is again common side. Okay, then what we can have is we can say that angle BAD equals to angle CAD. Why? Because we can say that AD is a perpendicular bisector, okay, now, and so these two angles are equal, so this angle equals to this angle. So we have three conditions, 1, 2 and 3. So we can say that triangle ABD is congruent to triangle ACD by ASA rule. So these two triangles are congruent by ASA rule. So we can say that AB equals to AC by CPCT. Now if one pair of opposite sides are equal, so it's an isosceles triangle. So we can say that triangle ABC is an isosceles triangle. So this is how we can prove these type of questions. So let's move on to the next question, question number 2. Now, the question number 2 says that we have a triangle ABC is an isosceles triangle in which altitudes BE and CF are drawn to the equal sides AC and AB respectively. Show that these altitudes are equal. So we need to prove that this altitude and this altitude are equal, and ABC is an isosceles triangle. It's given. So first of all, let's write what is given. Okay, now, so given is ABC is an isosceles triangle and it's given AB equals to AC. Now we need to prove in triangle ABC, we need to prove that BE and CF altitudes are equal. Now let's see how we can prove these type of questions. Now these type of questions are very easy to prove, but needs little bit of tricks, or we can say that we need to look after the triangles very carefully. So to prove these type of questions, so first we need to consider which triangles we need to prove so that we can have the altitudes BE and CF. So we can say that consider triangle ABE and triangle ACF. Now we have two triangles, and ABE and ACF. In these two triangles ABE and ACF, we have altitude BE and FC. Now, so let's say how we can prove these two triangles, and for convenience what we can do is we can break the triangles. So let's say how we can break the triangles. So let's say we draw a triangle like this. Okay, now this triangle can be A, E, B, and let's say we have another triangle like this. So this triangle, let's say, can be A, F, C, and this is 90 degree, and this is 90 degree, right? So we can easily prove it now, and it's given that AB and AC are equal. Now, so let's say how we can prove that. Now, first of all, it's given AB equals to AC, so we can write it as given. Now we need the two more conditions to prove the congruency. So let's say how we can do this. So we can say that angle A equals to angle A. Why? We can say that these are common angles. Okay, we have two conditions. So for the third condition, we can say that angle AEB equals to angle AFC. So each 90 degree. Why each 90 degree? Because BE and CF are the altitudes, so they are each 90 degree. So we have three conditions, 1, 2 and 3. So we can say that triangle ABE is congruent to triangle AFC by AAS rule. Why AAS rules? Because we have two angles, this angle and this angle. However, the side is not included, so we cannot use ASA rule over here. So we need to use only AAS rule. Why? Because the side is not included. So you have to check the conditions very carefully while doing the congruency, and this is a very important part to always need to check for this. So we have the congruent triangle, so we can say that BE equals to CF by CPCT. Congruent parts of congruent triangles are equals. So this is how we can prove that if we need to prove the altitudes drawn on the equal sides AC and AB. So how we can prove that these altitudes are equal. So this is how we can do these type of questions. Now let's discuss the next question. Question number 3. Okay, now this question says that ABC is a triangle in which altitudes BE and CF to the sides AC and AB are equal. So now the question says that the altitudes are equal. So it's a totally opposite question. It's a totally converse of the question we have done before in the previous slide. So it's given that this side and this side are equal, and we need to show that triangle ABE is congruent to triangle ACF. That's the first part. Second part is we need to prove that AB and AC are equal. So this means that we need to prove ABC is an isosceles triangle. So let's say how we can do these type of questions. So first of all, we need to write what is given. It's given that in triangle ABC, the altitudes BE and CF are equal. So you can write BE equals to CF. It's given, and these are altitudes. Altitudes to sides AB and AC. Now, so let's see how we can prove this. Same way, we need to split the triangles to make it easier to do the congruency. So let's say how we can prove this. So we first of all we need to prove the two triangles ABE and ACF are congruent. So let's say we have like this. So we can say that this is A, B and E, and we have another triangle like this. So we can write A, F and C. So it's given that this is 90 degree, and in AF this is 90 degree. So they are given 90 degree, and we are given that BE equals to CF. Now, so let's say how we can prove this two triangles are congruent. Now, so first part is to prove triangle ABE is congruent to triangle ACF. So let's see how we can prove this. Now, first condition is it's given that BE equals to CF. These altitudes are equal. It's given. Okay. Now, second is it's given that angle AEB equals to angle AFC, each 90 degree. Now, these two, let's say angles are each 90 degree, it's given. Now, for the third condition, we can say that angle A equals to angle A common. Okay. So we have three conditions, 1, 2 and 3. So let me draw like this with another pen. Now we have three conditions. This angle equals to this angle equals to this angle, and this altitude equals to this altitude. So we can say that triangle ABE is congruent to triangle ACF by AAS rule. Now over here again we cannot use ASA rule. Why? Because the side is not included again. So we have to really be very careful while using the congruencies. So which actually criteria follows the congruency. So you have to be very careful. So the criteria here following is AAS rule, not ASA rule. So we can say that these two triangles are congruent. Now, second part is we need to prove that AB equals to AC. So this was the first part and this is the second part. So similarly, if we prove AB equals to AC, that automatically proves that ABC is an isosceles triangle. So let's see how we can prove. Now we have two triangles ABE and ACF are congruent. So we can say that AB equals to AC by CPCT. Why? Because we have triangle ABE is congruent to triangle ACF. We have proved it, isn't it? Now, so this means AB equals to AC. So we can say that triangle ABC is an isosceles triangle. Okay. So this is how we can prove these type of questions. So these questions are very important from the exam point of view. So you have to be very careful while doing these type of questions. So let's do the next question. So the question number 4. Okay. Now this question is totally different questions. The questions we are trying to do before in the previous slides. So please watch this question very carefully, and I have seen this question coming in the examination very frequently. Okay, now it's given that ABC and DBC are two isosceles triangles. So this triangle and this triangle are isosceles triangle on the same base BC. So we need to show that angle ABD, this angle and this angle ACD are equal. So let's see how we can prove this. So first of all we need to write what is given. It's given that ABC and DBC are isosceles triangle, right? So okay, with same base BC, that's okay, the base is same. Now we need to prove that angle ABD is equals to angle ACD. Now we need to prove this. So let's see how we can prove this now. So it's given triangle ABC is an isosceles triangle. Why? So we can say that angle ABC is equals to angle ACB. So let it be first equation then. Similarly, it's given that triangle BDC is an isosceles triangle? Okay, then we can say that angle DBC equals to angle DCB. So let it be second equation. So what we can do is we can add these two equations, adding, we can say equation 1 and 2. So we can say that angle ABC plus angle DBC equals to angle ACB plus angle DCB. So we added two equation, equation 1 and equation 2. So angle ABC, this angle, adding this angle, and this angle, adding this angle. So this becomes angle ABD is equals to angle ACD. So which we needed to prove. So this is how we can prove these type of questions. The questions which seems to be very difficult to prove are actually easy to prove. So this is how just you have to analyze, or you have to see how we can prove the triangles. So very important for congruency of triangles, you have to actually first have a picture like which two triangles we need to consider to prove our congruency. So if you take the questions like that way, or think questions like that way, so the congruency will be very easy. Okay, now let's discuss the question number 5 of this video. Now in this question it's given that ABC is an isosceles triangle in which AB equals to AC and side BA, like this side BA, is produced to point D in such that AD equals to AB, and we need to show that BCD is a right angle. So we need to prove that this angle is right angle. So let's see how we can do this. So first of all we need to write what is given. Okay, now it's given ABC is an isosceles triangle, so we can say that AB equals to AC and side BA is produced to D, so it's given AD equals to AB. Now so this is given, so we need to prove angle BCD is a right angle. So let's see how we can do this. Now so let's discuss the proof. Now proof is angle ABC is an isosceles triangle, right? Now so if this is triangle, so it is given AB equals to AC. So we can say that if two sides are equal, then opposite angles are equal. So we can say that angle B, or we can write angle ABC equals to angle ACB. Why? Because AB equals to AC and angles opposite to equal sides are equal. So we can write these two angles are equal. So let's say we can write angle ABC equals to x. So angle ACB will always be equals to x. So we can say that let's this angle be x. So this is also x, or we can mark this as angle x. Now so we have now consider triangle ADC. Now it's given that AB equals to AD and AB equals to AC. These are given, right? This is also given. So we can say that AD is also equals to AC. So we can say that now triangle ADC is an isosceles triangle. Isosceles triangle. So now this means these two sides are equal. So opposite angles should be equal. So we can say that angle ADC is equals to angle DCA. Okay, now let me change the color now, so it will be better for you. So we can write now, let angle ADC equals to y. So this implies is angle DCA is also equals to y. So we can say that this angle is y, and this angle is also equals to y. Now, so now let's see how we can discuss the further proof. Now, since sum of angles of all triangles is equals to 180 degree, so we can say angle sum property is always equals to 180 degree. So we can say that if we consider triangle BDC, in this triangle all the angles will be, sum of all the angles will be equals to 180 degree. So we can say that now angle BDC plus angle DCB plus this angle BDC, DCB means this angle, this complete angle, and angle we can say DBC equals to 180 degree. So now what is angle BDC? It's y, it's given. Now angle DCB will be equals to this angle DCA plus angle ACB. So we can write it as y plus x. Now this angle is y plus x and this angle is y. Now what is DBC? DBC is x. So we can write it as x equals to 180 degree. So this will come out to be 2y plus 2x equals to 180 degree. So we can take 2 common out. So it will be x plus y equals to 180 degree. So this becomes, so this implies is x plus y equals to 90 degree. Now, so now let's see how we can prove that angle BCD equals to 90 degree. So right angle. So how we can prove that? Now it's given that, and we have taken or assumed that angle ACB is equals to x and angle DCA is equals to y. Now if we add these two angles, angle 1 and angle 2, so what it will become? So let me write it over here. So it will become angle ACB plus angle DCA will be equals to x plus y. So angle ACB, this angle, plus angle DCA, this angle. So this will become angle BCD. So this will become angle BCD. And we have proved that x plus y equals to 90 degree. So we can put it over here. So which is equals to 90 degree. So this is how we can prove that angle BCD equals to 90 degree. So this is how we can prove these type of question. So this was the last question this video. I hope you have enjoyed the video. So keep watching further videos. Thank you for watching the video Nairobi video also. Have a nice day ahead.